Okay, hello. So welcome to our third video in this three-part series on recursion. In this video we're actually going to look at implementing a recursive tree in processing. So let's get ready. There are a couple of parameters sort of to the tree that we want to add as variables at the top. And those parameters are, first off, what is going to be our base case? What is our minimum length of a branch on a tree, right? So we can make that a float, and we can just call it something like min branch len, makes sense for the minimum branch length. And we can make that, let's just say 10 for now, that's fine. The other parameter that we're going to want is the angle at which the branches sort of come off of their parent sort of trunk branch, right? So we're going to have a trunk, and then we're going to rotate a certain angle to get the next branch and the next subtree. So we want to say, well, what is that angle? So we can call that float angle. Makes sense. And then also processing is going to, by default, use radians, but I want to think in degrees, so I'm going to use the radians function, and that'll convert whatever you give it into radians, so that we can use degrees here. And why don't we just start with, like, let's say angle of 30 degrees. So that's pretty good. Thirdly, what we're going to want as our parameter is the ratio of one branch to another branch, right? Because every time that we go down a layer, the smaller recursive trees, they get smaller, so they have a smaller branch length. So what is the ratio between the larger parent branch and the smaller child branch? So we can just say, let's say branch ratio. And we can start that as like let's do 0.6 or something. Okay, so we have these parameters to our system, and now we're going to actually define our function that we're going to use to draw this recursive tree. And it's going to be one function, and that function is specifically going to call itself within itself, right? That's what makes it recursive. It's using itself to construct itself, right? So let's create a void function, and it's just going to draw the tree, right? So we'll just use it in draw, and then we'll draw the tree every frame with those given parameters. And later we can change the parameters with every frame, so you can see the tree moving and whatnot. But this function is just going to draw a tree, and let's give it an argument, and let's have that argument be the current length of the trunk branch. You know, when we draw that line and we draw two smaller recursive trees, the length of that line will be this argument. And that can be a float, since we're going to be multiplying it by that float branch ratio every time, right? So what's this going to do? It's going to draw a tree straight upwards, right? With trunk length L. Cool. So let's think about how we actually want to start constructing this function. I think the first thing we should address is the base case. When do we stop? Because if we're telling this function, hey, draw a tree, and it has a really, really small L, right, which we said would be our base case, when our length of that trunk reaches a certain length, we don't want to draw the tree. We want to say, hey, no, we're going to stop. This is the base case. So the first thing we should check is that. So let's say if L is greater than, and then our base is the min branch len, right? So we'll say min branch len. Then we want to do the things inside this function. But if it's not, it's the base case, and we just want to stop drawing branches, because otherwise it would go on infinitely, right? So stop at the base case. So within that, what are we going to need to do? So we have to draw our line, right? We have to draw our base trunk. Then we have to go to the end of that trunk, right, and rotate to the left, draw our smaller recursive tree. That'll be our drawTree function call number 1. Right? Then we'll rotate over to the right and call drawTree once again. So we're calling drawTree twice within itself, right? But to start, we're going to be drawing a line straight up. So we know how to draw a line, right? In processing, it's just line, and then the x and y of the starting coordinate, x and y of the ending coordinate. So since we're assuming that we're going to be using translations and stuff, let's just assume we're drawing from 0, 0 straight upwards. So the starting coordinate would just be 0, 0, right? And then we don't want to change the x at all, we just want to draw up. So we want to draw with a negative y, right? Because negative y goes up, positive y goes down. So we want to say 0, so don't change the x, and we'll draw to negative L. Right, so that draws the trunk of the tree. So that's our line straight upward. And we can test this by just seeing if this line works, right? It seems like a good idea. And so let's go into draw, and let's do first a push matrix, because I'm going to be translating, so we'll need our pop matrix as well. As I covered in the last video, if you're not sure about this, you might want to go back and watch that, or do some research on push and pop, because those are super important. So we're going to translate to the center of the window, right? So which is width over 2, height over 2. And then what we're going to do is just call our drawTree function, and we can just say, I don't know, 200 pixels. And I'll make sure that my stroke is white up here so I can see the white line on the black background. And let's just see how that looks. So in draw, there we go. So we have a straight line drawn from the origin, right, which we shifted over to the middle of the window so we can see it go straight up. And so then what we need to do is move to the end of that line and rotate it and then draw our trees, right? So how are we going to move to the end of that line? Well, that sounds a lot like translating, right? We're moving our coordinate system so that the origin will now be at the end of that line. So what we're going to want to do is say, once again, push matrix, right? Because anytime we're going to translate and we want to revert later, we're going to use push matrix and pop matrix. And then where are we translating? Well, the end of our line, right, it was 0, 0 to 0, negative L. We want to go to that end of the line, which is 0, negative L. So we can translate to 0, negative L, right, which is move to end of branch. And then from there, let's see, what do we need to do? So first we got to rotate, right? We're rotating over to the side by the amount angle, right? That's one of our variables. Now, since we're rotating to the left, we're going to use the negative angle because rotating angle will move us to the right. And I just want to do the left first. I'm not sure why. So let's rotate negative angle, right? So rotate left. And then now is when we need to draw our new recursive tree, right? So we're just going to say drawTree. And then here is where we actually change the size of the tree, right? Because we're not going to say drawTree L because then L will never get any smaller and the tree will just go out and be huge and it'll never stop and our computer will freak out. So we don't want to do that. We got to move towards the base case and when we get there we got to stop. So let's say L times that branch ratio that we said earlier, right? So this means with our given branch ratio of 0.6, it's going to scale down our length by 0.6 each time. So that's perfect. We can draw a smaller recursive tree, or recursive tree to the left. And now we're going to do almost exactly like we just did. We're going to do the same thing on the right side, right? So now we need to rotate back to the center, and then we can rotate again angle. So that's going to be rotating angle once, and then rotating angle once again. So we can just say rotate 2 times angle, and that'll do it for us. That'll get us back to the center, and then over to the right, the correct amount. Rotate back to center, and then over to the right. Right, so that's perfect. So now we're over here, and we can once again draw our tree, and it'll be exactly like this one. So I'm just going to copy that and paste it down here. So this is draw a smaller tree on or to the right. So there we go. We have our smaller tree over there. So every time we call drawTree, right, we take in a length for us to draw that first branch. If we haven't reached the base case, so if we're not at that minimum branch length, we're going to draw a line straight up from where we are, where our coordinate system currently is. Then we're going to move to the end of that line. That's translate 0, negative L. Then we rotate negative angle that way, right? And we draw a smaller tree. That's why it's L times branch ratio. It's a smaller tree. Then once we're done drawing that tree on the left, right, we rotate back to the center. That's once for angle. And then over to the right. Again, 2 times angle, right? So rotate 2 times angle. And we're going to draw a tree that is smaller to the right. So draw a tree, L times branch ratio. And then that should be it, right? All we've got is a trunk and then 2 smaller recursive trees. We've defined recursive tree in terms of itself. And that is really sort of the crux of recursion. So let's test this and see how it works. So there we go. It looks like it works. It's kind of up off the window, so I'm actually going to change where I translate it to. I want to be in the center horizontally, but it might be good to go just to the bottom of the window. So I can translate width over 2 and then just height. So let's draw that again. Okay, so we have our recursive tree. It looks like it drew it correctly. It seems to have drawn a trunk and then turned over, rotated, drawn another recursive tree, rotated back, drawn another tree. So it looks like it's working. There are a lot of sort of variation and lots of different expansions we could add upon this, right? We could have, like I said, like we saw in my original sketch, you could have the angle change based on the mouse position, and that's what gives that tree like, it gives it that look where it's sort of like moving around and the angles between the branches are changing. We could do things with colors where we change the color of each branch, or maybe make that interactive with the mouse in some sort. So there are a lot of different expansions, but the main idea here is recursion and that self-similarity and the idea of defining something in terms of itself, which is really what I want to get across in this video. So feel free to take this project and expand upon it, look into other recursive structures. They're all very similar. and self-similar, but so it's a really cool thing. Definitely check that out, and I hope you learn something about recursion in this video.